So, once upon a time, the world was on the brink of global nuclear warfare. It was 1962, and the United States and the USSR were embroiled in the Cuban Missile Crisis. And both countries were building hair-trigger missile systems and pointing them at each other. And the US was concerned with post-nuclear scenarios and whether they would be able to communicate in those situations. And so they have these top-down command and control systems that they use for communication. And this was a problem. So researchers came up with a solution. And that solution was to distribute the network and to have a bunch of nodes that were unmanned and that could route around network failure. And so we call these systems decentralized or distributed systems. And they solved this problem for us. And the problem was of making resilient networks, networks that could withstand failures and route around them and continue working in these doomsday scenarios. But what the researchers didn't realize was they'd invented the seed of a technology that would evolve into the internet, or the information superhighway. And this was an amazing breakthrough for commercial businesses, and part of the reason was because there were no middlemen. So in order to get onto the network, all it was required was having a computer, showing up and plugging it into the network. There was no one who could prevent you from doing that, and so innovation thrived. We had a diverse ecosystem of lots of apps and lots of innovation in network protocols, lots of basically people-powered innovation. So we call this architecture today peer-to-peer, and has a lot of advantages. And the internet actually still works this way today. At a fundamental level, every node on the network can talk to every other node. The advantages of this are censorship resistance, privacy preservation, and users being in control of their data. And peer-to-peer applications really have this last one, which is my favorite feature of peer-to-peer systems, which is they're safe against user-hostile changes. So if you have the intelligence of an application in the endpoint, in the client, it's really hard for someone to come in and say, we're going to change everything and make it like this now, because there's no point of control with which to do that. There are a lot of peer-to-peer applications that you may be familiar with today, like some of these. But there are many more applications that just use peer-to-peer, but are really centralized applications. Applications that are controlled by single companies or single entities. And there's a lot of reasons why these applications use peer-to-peer. So in the case of communication apps like Skype, it's for lower latency, better call quality. Things like Spotify, it's for cost. Same thing with Windows Update that uses peer-to-peer now. And there are just uptime benefits as well for game updates. When Blizzard releases a new game update, without peer-to-peer technology, everybody would try to update at the same time and not be able to get online. And centralized apps are pretty much all the rest of the world that we're familiar with. So pretty much every website we use is centralized. So this is kind of the landscape. This is how I think about the landscape of, on the spectrum of fully peer-to-peer, partially peer-to-peer, centralized. So centralized applications have a limitation. That's that there's a central server that makes all the decisions, and the client that's kind of subservient to the server and relies on it to do pretty much anything. So it's simpler to build, but it's limited, as we're going to discuss going forward. And this is actually part of a bigger trend in the evolution of computing. it used to be that we all used mainframes before my time, but I heard that there were these things called mainframes that people used to use. We had these kind of dumb terminals that we would use to connect to the mainframe. And all the magic happened on the mainframe, and the terminal was just a way to get to the mainframe. Then the pendulum swung to the other side with the PC revolution and a PC in every house. But now, oh yeah, and the thing that's cool about that is, right, that there's a lot of intelligence at the endpoints. And this was kind of when we started to see the development of really cool peer-to-peer applications that lived, on top of the internet. But now the pendulum's kind of swinging back the other way, and cloud is really just another word for mainframe. And part of the reason for this change is mobile devices. Mobile devices are not as powerful as desktops, and so for that reason it makes a lot of sense to move some of that computation into the data center. But I want us to think about maybe how we can start to shift the pendulum back toward peer-to-peer. And I think this is a thing where it's going to keep happening like this, back and forth, the different stages of computing as it evolves. But I don't think it's going to happen if we don't make it easier to build peer-to-peer applications. So if you look at the list of peer-to-peer applications from earlier, you'll notice that with pretty much all of them, maybe with the exception of a few, these don't work in the web browser. The web browser is the most ubiquitous VM or runtime for running applications today. It's everywhere. And so I think it's really important, if we want peer-to-peer applications to spread, that we were able to build websites that are powered by peer-to-peer. And so it's worth thinking about why web apps aren't peer-to-peer today and why they're not able to be. I think the main reason is that they're basically trapped in the browser, right? In general, when we're on a website, we don't trust it. We don't know who made it, and we want to have kind of limitations set on what that website can do. And there's also other fundamental architectural things like the domain name system and DNS. And even the URL. As awesome as the URL is, the URL defines a resource on the network by its location. And so if that location goes away, that resource becomes completely inaccessible. Even if it does exist on some computer somewhere in the world, you can't find it. And that's the broken link that we all know about, the dreaded 404 error that we see pretty much every day. So the web was not designed to be peer-to-peer. The web was designed to be a client-server architecture. But what if it was designed to be peer-to-peer? There's this quote I love from Bruce Stercall of the Internet Archive. He says, "The way we code the web will determine the way we live online. So we need to bake our values into our code." So freedom of expression needs to be baked into our code. Privacy needs to be baked into our code. Universal access to all knowledge. But right now, those values are not embedded in the web. Or they haven't been. But this is starting to change with WebRTC. How many people have heard of WebRTC? Okay, cool. So I think that this is going to be the way that we can kind of shift the pendulum back toward the other side, the peer-to-peer side. So data channel is how we're going to do it. It's a part of WebRTC. It's really a hidden gem, I think, because not that many people are using it today in their applications. It's really easy to use, though. That's one of the things it has going for it. It's just as easy as using a WebSocket, if you've ever done that before. You can send stuff. You can receive messages with a straightforward API. And the main thing going for it is it's the only peer-to-peer transport that works in the browser. So if you want to build peer-to-peer web apps, you have to use this. And this is a new thing. It's starting to spread. We almost have it in all the browsers. So this vision is starting to become possible. If you guys, those of you who raised your hand probably already know this, but WebRTC gives you some really nice properties that features that you really need for any peer-to-peer app that you're building. So you need to be able to traverse NATs in order to connect people to each other. Get that for free. You don't have to worry about the cross-origin policy, which is really cool. So a web app on one domain can actually talk to a web app on another domain using WebRTC. You get encryption mandatory by default. And really, the magic is that it's universal. You can't, you can use WebRTC everywhere. You can use it in your mobile app, in your desktop app, in your web app, in your server app, in your command line app. And so we can really base all of our new protocols on WebRTC if we want to. It really works everywhere. This makes it ideal for building new peer-to-peer applications and new peer-to-peer protocols because it's kind of universal. It's a universal protocol we can rely on being there everywhere, including the browser. And so because of this, we used WebRTC when we were building WebTorrent. So WebTorrent is a torrent client for the web. It's the first torrent client to work in the browser. And it's pure JavaScript. And I've been working on this project for like the last 2.5 years now. So it's come pretty far. I'd like to give you guys just a quick demo of how easy it is to get started playing around with WebTorrent. So I'm going to, let's see, here we go. Cool. Everyone see this? So I'll just do a really quick little code sample here. So we have, we're including a single script tag which loads the WebTorrent library. It's really small. It's just 75 kilobytes, an entire torrent client in just 75 kilobytes. And then here I have a magnet link which is pointing to a Creative Commons movie called Cintel. And so what we're going to do is we're going to create a new WebTorrent client, just like this, and we're going to add the magnet link to that client. And then what's going to happen is WebTorrent's going to go out to the network, and it's going to find people who have that torrent, and it's going to give us a callback once it's fetched the metadata for that torrent. The metadata includes the list of files that are in that torrent and the size and other various properties about it. So then what we're going to do is get the first file, because we know that this torrent, I happen to know, has just one file in it, and the movie is the first file. Then I'm going to append it to the DOM. And I'm just going to say add it to the body, and it'll do a lookup using like a CSS selector, and it'll add that to the page. So if I do that, oh, files, I think. Should. Bam. Okay. So just like that, running this code, it pulled the file out of the torrent and it added it to the body of the page, and it's auto-playing down there. You can see this movie, it's just playing just like that, right there in the browser. Yeah, pretty cool, right? Cool, so I'm going to kill that now, go back here. So yeah, just code just simple as that. You can get started downloading torrents in the browser. And that was a peer-to-peer transfer. There was no, file was not coming from a central server, that was coming from other people who were seeding that file. And some of those people are on web pages out there on the web. Some of them are coming from desktop apps that are installed on people's computers. We'll talk about that in a minute. But it's important to know the WebTorrent protocol is basically 95% BitTorrent. So it's almost the same as traditional BitTorrent. And so the main difference is instead of using TCP or UTP to talk between peers, we're using WebRTC obviously, so we can work in the browser. The other thing we changed is the way the tracker protocol works. So this is how BitTorrent clients go out there and find peers. They find people to connect to. So instead of using HTTP or UDP, like traditional BitTorrent, we use a WebSocket server, and that's because of how WebRTC connections work. So with an HTTP tracker, it's really simple. You can just send a message to the tracker and say, this is the info hash or the identifier of the torrent that I'm interested in, and here's my IP and port. And then the tracker will respond with a list of the peers that have that content, and then the tracker will also add you to the list of peers to give out to other people, to other peers to come along and ask for that list in the future. Really simple. But WebRTC has offer answer. And so that means that we need a way to receive remote offers and have the server push that to us. So when we do WebTorrent, we open a WebSocket connection to the tracker, and we send it the hash of the torrent we want to download and a bunch of WebRTC offers, like about 5 or 10. And then the tracker will send us up to 5 or 10 WebRTC answers back from remote peers. And then we keep the WebSocket open so we can receive offers in the future from new peers who connect to the tracker. But once the peers connect, the wire protocol that they speak to each other is 100% the same as normal BitTorrent. So yeah, that's why we needed to add a new way of talking to trackers, and that's the WebSocket there. So WebTorrent is on NPM. It's lightweight, it's pure JavaScript. It has all the features you'd expect from a torrent client. And it also has this really cool feature, which is you can stream from files. So you can actually, on demand, get the pieces of the files that you need, and that's really good for video streaming, as you're going to see in a minute. So we also have a desktop app. And this might seem kind of weird because the point of WebTorrent is to work in the browser, right? But the desktop app is really important. The reason why is that it bridges the traditional torrent network with the browser network, because those two can't talk to each other. This app lets us put both TCP, UDP, and WebRTC into one app. And so anyone using that app will share what they're downloading with both networks. So we have this beautiful app that has a built-in player. It lets you stream movies, and it has Chromecast support and AirPlay support. And this is what it looks like when you have a bunch of torrents added to it. These all happen to be Creative Commons movies and albums. Those are the AirPlay and Chromecast controls I told you about. And I'm going to show you it now. So, here we go. There we go. So here's the app. And I can push play on this movie here. I happen to not have this downloaded right now, so if I push play, see what happens. Movie starts to play. Notice something here. See this progress bar? See if I can zoom in. What's really interesting is that it's not contiguous, unlike YouTube or any other video site you might have used. These are actually torrent pieces, right, that are getting pulled in basically sequential order, but not perfectly sequential. So you can kind of see it there. You can kind of see the protocol in action. So now if I zoom out and I seek to a future spot in the video, let's check out what happens. Do you see how it reprioritized the pieces that need to fetch? So it's pretty cool. I think a lot of people don't know the torrent protocol can do this. Cool. So yeah, that's the app. Thank you. So yeah, we just released this 2 months ago, and right now we have 50,000 installs of the app, and we're going to keep improving it and trying to make it better. And the more that app gets used, the more that content that's in that app will get made available to the web network to be truly downloaded from the web peer-to-peer. And so I want to talk just a little bit now in my remaining 5 minutes about how we built that app, because I think there's lessons in here that are really useful to anybody who's building WebRTC apps. We use this thing called ELECTRON. How many people have heard of ELECTRON? Okay, cool, wow, okay. So it lets you build cross-platform desktop apps really easily. And it's really perfect. It was perfect for building WebTorrent desktop. And that's because of, it's also perfect for, honestly, any WebRTC app. If you have a WebRTC web app, you should really consider making a WebRTC native app using ELECTRON. So because it has a combination of Node and Chrome capabilities available to you. And Chrome includes WebRTC, so therefore ELECTRON includes WebRTC. So because WebTorrent works in Node.JS and the browser using the same NPM package, we're able to just drop it right into ELECTRON, and it detects the capabilities that are available in that environment, which happen to be TCP and UDP from Node and WebRTC from Chrome. And so we can actually, just by dropping that library in there, we automatically are getting both transports right out of the box. So you can probably take most of your web app code, drop it into an ELECTRON app, and it'll just work. So I call this a hybrid torrent client. Because it can talk to traditional torrent clients and to browser torrent clients. But the thing is, ELECTRON is more than just a dumb, Chromium web view. If that were it would be cool, but it wouldn't be that cool. What really puts it over the top for me is the OS integrations that it has built in. You can use ELECTRON to make a really nice native feeling application, and with all the niceties that you would expect from an app that is native to the platform that you're building for. So WebTorrent Desktop works on Windows and Linux and Mac, and it feels at home on all those applications. It's really the vision of, like, I think Java, in the old days of, like, write once, run anywhere, but executed actually pretty well. So you can see, like, there's you have an icon, of course, like you'd expect all apps to have. You have, like, OS menus. I'm just showing you OS 10 because that's what I use, but it works, in all the ways you'd expect on other platforms. Here's a progress bar showing how the download is going. Here's a little badge that shows you how many torrents have completed while you were away from your computer. You have notifications. You also have a built-in auto updater. This is really nice because you make sure your users are always on the latest version of your app, and it works really well. It's silent, and just like the Chrome auto updater, you don't even know it's there. So yeah, I would encourage everybody to think about WebRTC as more than just like a thing for the web, thing for the browser. We found with the WebTorrent project that thinking beyond that and building a native app has really helped the strength of the network. The number of people who've used the desktop app in the last 2 months is like I said, 50K, and that's more than everybody who's used the JavaScript version of our app, the NPM package that was available for like 2 years. So it's really making the network strong, and I really think that new peer-to-peer protocols that are built should really consider using WebRTC as the underlying transport, because then they'll be able to work everywhere on all platforms, including the browser. So you can learn more about WebTorrent at this URL, and thanks for having me.